So today we're going to be looking at waves, and we're going to give you a bit of an introduction on what waves are and talk about a few different types of waves and how we can classify them. So you might have an idea of what a wave is. You can probably think of multiple examples of waves. So you might have heard of like water waves at the beach. You might have heard of, say, microwaves. You might even think of, say, sound waves. So sound waves, by the way, is something that we'll be studying quite a lot of in this module. But while those are all examples of waves, they don't really answer the question of what actually is a wave itself. And so the concept of a wave is actually something quite abstract. And that's something we'll also look at a bit more in year 12. But for now, just think of like a piece of string. Okay?
Yeah.
If you have a piece of rope or string, and you, I guess, you're playing skipping rope or something, and you move it up or down, then you can probably imagine that after a while, this will start to form this sort of shape. And let me show you what I mean with that. So let's say that you've over here on the left, and we will get rid of that. So let's say you're over here on the left. Here's your little string. We can move this sort of up or down. And you can see that as we move it, depending on how we move it, you get this sort of shape of a wave that's going to the right. I can move it not regularly, and then the wave will not be regular, or I can try to move it more regularly like so. Or I can get a machine to do it really regularly. But these will all send sort of waves to the right. That's our idea of what a wave is. Okay. So what has actually happened though? If we look at this, before we started, this thing on the right's not moving. We move the left-hand side, no matter how you move it. And after a bit of time, the right-hand side, which wasn't moving before, now starts to move. So what we've done is we've made the right-hand side move over here by moving the left-hand side. And we've skipped energy, but basically the idea is movement requires energy. So before there is no energy here to start with, we put in energy here. And that energy gets transferred to the other side. And then you end up with movement here because the energy has been propagated here. So one way to think about a wave, what a wave does, or one thing that a wave does, is it transfers energy from one place to another. Now, the next thing that's not enough, but the next thing we need to say about that is the how it does that. And if you were to look carefully as we move this up or down, or if you think about you holding the rope, I guess the question I want you to think about is, does the rope move to the right? Or does it kind of stay more or less in the same spot? Because you can always transfer energy around very easily by just physically moving the energy. You can, for example, grab a tank of hot water, which has energy in it. You physically carry it to the other side of the room, and then you have moved energy from one side of the room to the other, right?
Yeah.
But that we don't think of as a wave. We physically moved an object, right? So if you've got hot water and then you move it to the other side of the room, you have moved energy, but that isn't actually a wave. So what is a wave? As we said, a wave moves energy from one place to another. So it's a carrier of energy.
Mm-hmm. Yeah.
but importantly, without the net movement of matter. In other words, the rope doesn't physically move to the right, although it's happened to move it to the right. Now, we will now need to look at how we can classify different types of waves. There are a few different ways to classify it based on, I guess, the oscillation that's involved. I guess we could do it by the time period that's involved. And we can also do it by, I suppose, the particles, or like the oscillation direction, or the oscillation sort of medium, if you like. So let's talk about, firstly, the fact that most of the time when we're doing waves here, we're going to mostly focus on what we call mechanical waves. So waves, one question you might need to ask is, are they mechanical? Or the opposite of mechanical is electromagnetic waves. So mechanical waves are probably easier to explain and will be the ones we'll be focusing most of our study on for a while, although we will definitely talk about electromagnetic. So it's either mechanical or electromagnetic. Mechanical basically means that the wave is going through an actual medium, like with actual particles. So that could be air, that could be a rope, that could be water. But there is a sort of medium that it goes through, which is required. And it's required, we'll talk about this when we talk about the propagation, but it's required because of how this wave works, like how it moves. So it's the particles in the medium that help the propagation. Whereas for an electromagnetic wave, it doesn't actually need a medium. And the reason for that is because there's no sort of particles that are actually moving. It's actually something called fields. Okay. So let's talk about how these waves move around. And let's take a look. So let's take a look at this wave. So right now, it looks quite clear to us that this wave is going to the right. Yeah. So if we call this A, something is happening and the wave is getting towards B. It's moving from A to B. But the real question is, how does it do that? So let's stop for a moment. The wave looks like this at the moment. Now, it's probably not surprising that the wave, because of what we said so far, since it's going to the right, will look something like this in a short moment. The question is, though, if the blue line is going to become the green line, how does it do that? Because remember, there is no net movement of matter, right? Before the wave, the rope is flat, so to speak. After the wave goes through, the rope is still flat. And the rope basically hasn't moved. So how did the wave move to the right if the rope basically doesn't move? Well, it comes down to basically the oscillation or vibration of the individual particles. So look at, for example, this pink dot here, and watch what happens as we step. You can see that that pink dot has moved downward. And of course, my diagram wasn't perfect, but you can see that the blue has now moved towards the green.
Yeah.
So what we're really saying here is, how does the wave move to the right? Let's get a few more points in and take a careful look at what each point does. Okay.
So the point, they move backwards.
They don't move backwards.
Like the thingy with the blue line, it moves like backwards. So it makes me feel like the pink dots, they're moving, like they're going backwards.
Well, they're not moving backwards. Let's draw in these lines. Right? And let's step it a few more. What do you notice about the pink dots?
What? Oh my god! What? They actually don't move. Like they only move up and downwards.
That's the whole point. In this example, we're here. They're only moving. I mean, they are moving, but only up and down.
But without like the green lines, like when it was moving before, I feel like my eyes are telling me that they're actually moving like backwards.
Well, I guess that's why the green lines are there, right? So they might help you see they're not moving backwards at all, right? So
Yeah.
in the sense that, are they moving forwards or backwards? Then the answer is no. For example, this pink dot will just stay here. I mean, it will move up or down as required by the wave and to help the wave move along, but it's not moving forwards or backwards. And that's what we're saying. There is no net movement of matter here, right?
Yeah.
However, if you look at the blue wave, if you look at the wave as a whole, the wave clearly is moving to the right. The wave is moving to the right, but the individual particles are not moving to the right. In fact, once the wave is gone, the individual particles just go back to where they were, okay? And that is basically the idea of how waves propagate. Depending on the type of wave, they might do it in different waves, but the basic idea is the same. You'll get individual things sort of moving around somewhere, but they'll go back to the middle, like where they were, once the wave passes. They will vibrate or oscillate around a central position, right?
Yeah.
Okay, so we'll look at different ways of achieving it. This is one way to achieve it. Now, the other way to achieve it is shown here. Now, it might be more difficult to take a look, but let's see. So over here, you can pretty much ignore this for the moment and just look at the left. So if you take a look at the left, the wave is going up. Now, you're probably not so familiar with seeing this wave, but you can definitely see this sort of pattern moving upwards, right?
Yeah.
So we'll see this as a wave as it's going up. But now let's closely examine how this wave moves upwards. Okay.
Yeah.
Now, this might be one where you, well, right? If you just take a look, that looks like that. But now this might be one where if you take a look at this red one, now this seems to move like forwards and back, right?
Yeah.
So this red one does appear to be moving up or down a bit, but okay, so it is moving up or down a bit, but is it like flowing with the wave? Is it going like further up and up and up?
No, it's
No.
just like a little bit.
It's just staying around here, right? It's
Yeah.
going up and down, but it's staying around the same sort of spot.
Yeah.
And we can show that, because if we just track its position and mark it as we're doing here, it's going up, it's going back down, it's going back up, it's going back down, but it will basically stay between these two spots. Okay. Let's add on a few more points.
Yeah.
So you can see that the green one is also staying between sort of these spots. The blue one is staying between certain spots. And so it's the same kind of idea as before. The wave progresses upwards. That's the velocity of the wave. And how is it doing that? Because the particles in the medium are again oscillating, or if you like, vibrating. And the total number of particles together, which, make moving together to make the wave move forward. Now you'll notice that this wave is different to the wave we looked at before. And that's because they're two different types of waves. Okay. And this is another way that we can sort of separate out waves, which is how they're oscillating. So we have what we call transverse waves over here and longitudinal waves over here. Okay. Let's make them traveling waves. Okay. So we've got transverse waves at the top and longitudinal waves at the bottom. Those are different types of waves. What's different about them, apart from the way they look? Ultimately, with transverse waves, their particles are moving up and down as the wave moves across.
Yeah.
Now, with your longitudinal waves, they're moving left and right, in this case, along with the wave. So the key point here is, in terms of waves, you can split them up into transverse or longitudinal. Now this, whether it's a transverse wave or a longitudinal wave, comes down to the direction of oscillation of the particles. So for a transverse wave, you might think the answer is, oh, if it oscillates up and down, then it's transverse, or left and right, then it's longitudinal. That's not quite correct. But it's a very common sort of misconception because it's actually related to the wave velocity. For a transverse wave, we want the particle oscillation direction to be perpendicular to the wave velocity. So earlier, our wave was going to the right. Our particles were oscillating up, down. So up, down is perpendicular to going to the right. And that's why it's a transverse wave. For a longitudinal one, we want the particle oscillation direction to be parallel to the wave velocity. Okay, so longitudinal waves are much trickier to draw. We don't normally draw out longitudinal waves too much. But basically, you might recall in our example, our wave velocity was, well, going up actually. Our wave velocity was going up and our particles were oscillating up or down. These are parallel to each other and therefore it's longitudinal. So that's one very key point. We've got waves that are transverse or longitudinal, and we've got waves that are mechanical or electromagnetic. For our purposes, we're mostly going to be covering your mechanical waves. These are all things we'll be looking at in a bit more detail individually as well. Lastly, well, not lastly, but another way we would split waves up is, I guess, based on the duration of the wave. And I suppose it's time. And we'll definitely be looking at this in this topic. But one way, the most common wave that you'll probably be looking at is, we might call it a traveling wave. Or a propagating wave. And that's the sort of wave you'll be looking at mostly. It kind of just keeps going. Or the opposite of that is a standing wave. And we have a whole section of our topic devoted to that. But to give you an idea of the difference between those two, let's go back and take a look at this. So this is a traveling wave. Over here, the blue wave is just going to the right. And over here, the green wave is just also going to the right. But if we were to change it to standing waves, you'll notice that the blue waves don't seem to be going to the right anymore, but it kind of seems to be staying in place. And the green wave, similarly, doesn't seem to be going to the right anymore, but seems to be sort of staying in place. How this occurs is related to something called interference that we'll be looking at as we study more. Another way we could split it up is the duration, as we were saying. And it's either a continuous wave or a pulse. And that's quite simple to sort of understand. A continuous wave is just one that just keeps on going. And a pulse is just sort of short. And it has a start and end. So you might think of like a clap, all right? Or a shout, like a pulse, right? Whereas continuous would just be like, for example, having the air conditioner on, which just keeps going and going and going. What might that look like? Well, the difference might be something like this. Something like this would be like continuous, it just keeps going.
Mm-hmm.
Whereas a pulse might look more like, say, this. And then, there's a start. Oh, I got a wave, and then it stops. Or we can even make it even more pronounced, something like this. Good. So those are the basics of your waves. Now we need to start looking at different parts of a wave and properties of waves.